All right. Hello, everyone. Good morning. Hope you guys enjoyed the keynote. Made it more than in time to this room. Appreciate you all coming here and listening to how I talk to the rest of the world, or how VXLAN EVPN talks to the rest of the world. My name is Lucas Kradiger, and I will go and jump here in the middle in a second. So if you don't see me from the very back there, just complain, but please not in the survey. But I try to make it a little bit more engaging and giving you a little bit more pointers from the screen here in front, and we have a laser pointer that works, so that should be fun in that case. So 45 minutes is short. I try to be concise. I try to give you the best option. I try to give you two other options, and I try to tell you what are the issues with these options. And then I rely a little bit on your creativity being a network engineer and how to solve it. You will see that my way of solving it is always doing the KISS approach. Keep it simple and stupid, right? So let's go and start. If you want to go into the Teams room, the WebEx room, there is actually the PDF there. So you don't have to go search in the app or somewhere else. You just go in that WebEx room. You can send messages. You can ask questions. I think Max Ardika sits in the back and will answer them while I present. Cannot do multitasking. I'll leave that to my wife. But otherwise, you just go in the room, have a look there for the PDF, ask the questions, we'll answer them afterwards in the session. Abstract, you guys know what VRF Lite is, I guess. It's kind of multiple VRFs on a single link. Great. So you have a VXLAN EVPN fabric, we want to get all these IP subnets and host routes out of this VXLAN EVPN fabrics. So we need something like external connectivity, and very often people call that VRF Lite. Most accurate would be called Inter-AS Option A. I will use it interchangeably in here, and we'll mainly talk about how we are going to do that in the most efficient way. The other part, which I will go and very briefly touch, is the gateway capabilities we have. So from VXLAN EVPN to another VPN address family like Layer 3 VPN, VPN v4, VPN v6, or from VXLAN EVPN to EVPN, different NCAPs, SR MPLS, MPLS LDP, or MPLS traditional, or SRv6, or whatever you want to connect your outside world. There might be an existing network, and we might want to integrate with it in the same NCAP, or we just go into the least common denominator and do, what are we doing? Inter-AS Option A, multiple sub-interface, VRFs on them, multiple peerings, etc. So let's see how that goes. Fantastic. So I will go with a short overview in VXLAN EVPN, I think 3-4 slides, maybe more. I want to give you a little bit a look of control and data plane. It's important to understand how afterwards the flows work, what we advertise, what we learn, and where and how we are installing them. We're going in some of the best practices in external connectivity. So how I consider it best practice and why. I show you the why. I have configuration snippets and show command outputs. And by the way, all of this I tested in my lab, so it's not like I give you something I wrote together on my own somewhere in my little thing. It's all part of our either NDFC DCNM automation, or it's part of generic Inter-AS Option A best practices. I don't go into the configs or the likes on the last bullet point. I keep them there as information, but there is a lot of material we have. Actually, our config guys for the MPLS handoffs, is it SR or is it traditional MPLS, are now use case based. So you have a diagram, you have where the box is placed, how it interacts, instead of just giving you some blunt configuration commands. If you haven't had enough from me, I present, I think, 3 more sessions later this week, 1 in the afternoon, I think 2 tomorrow, I don't know, somewhere there, and somewhere on Thursday. So hit me up. The rest of the sessions which you see here are all around the same topic. So if you have a gap in one area, you can go to another session subsequently or review the sessions offline if you want so. So this is the agenda. We're going in very, very easy 3 points, and most of the things I already said, so we're going into the introduction and nail it here. VXLAN is a data plane. We call it standards-based, RFC, what is it again, 7348, and we are going to use that in encapsulation. You will see a lot of slides with that part in there. We have EVPN, it's a control plane, it's an address family in BGP. We have 8365 as an RFC, which defines VXLAN EVPN specifically. We have RFC 7432, which is MPLS and the base RFC. So they're very close together and have just the variations on the end caps. EVPN is the first true layer 2, layer 3 control plane with VPN capabilities. So it combines layer 2, or Ethernet, and adds layer 3 to it. And as a combined control plane, you not only get subnet information, you also get host information, meaning MAC addresses and IP addresses in there. Unfortunately, yesterday was the introduction to VXLAN EVPN, so I have to assume a little bit of you guys are aware of, but in all of these cases, we start with a network device. Whatever we do, there is a network device, and I call VXLAN EVPN kind of the dating network. It's kind of where the control plane, EVPN, and the data plane meets. And that's on a network device, and that network device has two sides. It has the uplink, the core side, the fabric side, and it has the downlinks, the access side or the host side. So exactly as you see here, it's exactly here in the middle, and when we put a VTAP on top of that, then that network device becomes a network virtualization edge. So it's at the edge between two sides of the network. But it's still a switch or a router or a network device or whatever you want to call it, a leaf, more or less a spine, but it's a network virtualization edge. And when we look at this from a more holistic network perspective, we have the host attachment, we have the part of the underlay network, the core network, the topology, and then we have an exit. We have an exit to an external world, and I don't know how to call it these days better, so it's external connectivity, the way to the outside. And remember, this guy here, still a VTAP, right? Could I connect hosts there? Sure you could, if you want to. I will not, but that's your choice. But in fact, it's yet another VTAP or yet another NV, it's just a little bit of special NV. And from that special network virtualization edge, or VTAP, we have somehow of a routing protocol to the rest of the world. That routing protocol has to be VRF aware. Given we have within the fabric, within VXLAN EVPN, you can have, on our side, over 2,000 VRFs, IP VRFs. How do you bring these 2,000 IP VRFs to the outside? Or, other said, how can my user in a certain segment connect to a certain application which sits in a VRF within the data center itself? So we need to have some kind of a VRF-aware routing protocol. Does it need to be a VPN protocol? No. So we don't look at VPN v4, VPN v6 specifically when we say VRF-aware. We look at, can I do in a single VRF a session to the outside? And can I do that multiple times? And how do I bring that multiple times to that rest of the world? So we're moving up. We want to have only that special border in our purview as we go through. We want to focus on that node up here in the middle, and that's where we're continuing for now with this VRF-aware routing protocol. Again, we're still doing actually intro to VXLAN EVPN. I don't know if you guys figured that, but they're all fundamentals which have to match together, and I want to make sure that you all understand that. Afterwards, how you create a BGP session to the outside, you will all get that in a second. So VXLAN EVPN, the borders, the border leaf, if you want, so the border NVE, there are a couple of tables which are relevant. What are these tables? Hardware tables, routing tables, RIP, FIP, right? Routing information base, forwarding information base. Do I really care on the MAC tables? Probably less. So I call them the routing tables. So I put the routing tables here, and as I learn from within the fabric, you see here the spine as a route reflector receives certain information from the leaves, sending that over BGP to our NVE here in the middle. You see here an EVPN NLRI, it is a type 5 with a 10.10.10.0 address. We will learn this subnet. We will learn this IP route by importing this in our VRF table. And how do we know in what VRF table we need to import it? It is the route targets which tell me that. So EVPN route target, import in a local VRF, route target import defines that I import this route. Now I have that on the border. I have it installed in my hardware table. What do I have to do next in order to tell everyone else, not just my fabric, but the rest of the world, hey, I'm there, so I have to go and advertise that, export that, and send it to the rest. So we had EVPN within the fabric. To the outside of the world, we probably don't have EVPN, at least not in this case, so our NLRI is much more simpler. NLRI is the network layer reachability information, or what you would call the route part of a BGP update. So you see here, I have this 10.10.10.0, 1112. 1112 is going to be what we learn from the inside. So when we do that advertise over that BGP peering to the external world, what do we need to do? We need to change the next hop, right? Because our next hop from the outside is here, our border. And then from the border to where the route comes from inside is our leaf. So we have different next hops which are going into these routes and in these information. In this case, we learn it from the inside, so we need to send it towards 1112 to the inside, and as we go here, we would see a different table as it comes. Now, when I did all of this, that was the learning from a leaf or a subnet which comes from within the fabric. I can also learn a subnet from outside of the fabric, an external subnet if you want so, and the things are pretty much the same, but inverse. So I have here the external router. I don't know exactly what it is, but I send an update over to my NVE. You see here, next hop 1222, we have 10.11.11.0. He will learn that. He will install this route in the respective VRF routing table. Remember, no VPNs, no route targets, right? This is pure per VRF session which we have here. And then when we export this route, at that point it becomes an EVPN route. At that point we are adding a route target. At that point we are changing the next hop to respectively being that NVE here. So when a leaf receives this route and wants to connect to the outside, it needs exactly that. It needs to go to the border and then the external world forward. So a little bit of forwarding. We'll have a packet walk later this week, so we'll go into the details there, but you have some traffic coming from the outside. You hit the NVE, you do a lookup, you encapsulate based on the information you have in your RIP and FIP and send it towards the leaf at that point. As said, a day in the life of a VXLAN EVPN packet, I think it's Thursday, which we're having that session. We will go into these details. I don't want to spend the time on this today because I want to go to the external connectivity scenarios. You feel I'm rushing. I'm just trying to get to the introduction a little bit faster to spend more time on actually the meat of the session, which is the external connectivity. Nevertheless, I cannot leave you guys just with maybe some information that are missing, so I want to give them to you, so that's why we went through this. Topology overview. It's my little fabric. I have my couple of leaves. Host A, host B, host C, D, leaf 1, leaf 2, spine in the middle, and I have my B1 there on the top and my external network attached. Why do I show it in this circle way? It's just easier to look at it for such presentations. Otherwise, I would never build a topology this way. But when we go and look at the essences of a fabric and the key criteria of what we want to know and look about, we care on the border, on the AS. We need to understand there's some iBGP happening in here. We have some external connectivity. So this is just a simple VXLAN EVPN fabric with one border leaf and one border leaf just for me being lazy drawing multiple. What we're going to focus from here on is just that little part, the border to the external world, because that's where the interaction between two different worlds happens. A redistribution or re-advertisement, a reorigination of different protocols, different caps. So that's where we're here, right? Connection to the external world. And I have three scenarios for you. First one is eBGP and subinterface. Anyone doing this today? Very good. Very good. Cool. So you guys will be bored, but maybe you get a new nugget. I don't know. So very simple, border 1, border 2, and we have our ER1, which is our edge router here on the outside. I have some interfaces, the main interfaces. So this is the plumbing, right? This is just how the plumbing goes from a physical connectivity. And then we add some sub-interfaces to these physical interfaces. So you see here my .2. Here, .2, does it have to be the same? No. DCNM did that, or NDFC did that automatically. I have here the .1Q2, .1Q2. Does anyone see a mistake on this slide? This should be .1Q2 here, right? The sub-interface dot notation doesn't matter. The encap has to be the same. Otherwise, your .1Q, your VLAN encapsulation between the two doesn't work. So, Max, please fix my slide. Sorry, I'm just kidding. But apart from that, you have point-to-point subnets, right, on the IP addressing on these physical interfaces. And you have here a little bit of configuration. And I think my configurations are right. Yes, here you see 2, you see 2, you see 2, you see 2. And this is exactly copy-paste out of the CLI from my switches. And I guess that's why I missed this little nugget here, because that came after the configs. But you get the story, right? IP sub-interface, nothing magic. How many sub-interface can we do? We had 512 till very recently. In the meantime, we are at, I think, 2,000 sub-interface or even 4,000 sub-interface per switch. So you can extend the 4,000 VRFs, the 2,000 VRFs over the 4,000 sub-interfaces with some BGP session, and you have redundancy in the case, so you should be fine in that case. Now, what we also do is we do a DBGP session, external BGP point-to-point. Why point-to-point? Because we want to marry the link status to the BGP session, right? If link goes down, BGP should go down. That's fast convergence. If you do this, you probably don't even need BFD for the down detection. If you have some other cases like brownouts, optical outs, or others, you might still use BFD, but you don't have to. BGP has a function which is called update source, which listens to the interface notification, which will take care on that. And you see this exactly here on what I'm using here. That's a neighbor session within the VRF itself to the neighbor 10.133.2, which is the other interface on the other side. So if my interface goes down, the other interface goes down, we both get an interface down event, BGP down, all good. No magic so far, right? Everyone good? More or less? Yes? Okay. Well, how does it look? Very straightforward. So we have here the internal route, which goes to or comes from our VTAP. We have here, what is that one? An external route, 10.10.10.0, which we learn. You see here, eBGP. We have next hop. Oh, actually, we have more next hops here in that case. Why do we have 2 next hops? Anyone? Max path, ever heard of that? ECMP to the outside, so you have 2 ways out. And then here you have the internal routes at that point. So this is all very straightforward if you think of this, right? There is no troubleshooting you have to do much to get this going. It's the commands you know. It's what you would do naturally if you have 2 routers and connect a BGP session between these 2 routers. The only difference is we are actually going to take these routes and send them into EVPN by doing a reorigination, or we take the EVPN routes and send them as normal VPN, as normal IPv4 or IPv6 routes outside to the rest of the network. Does everything look good here? Do we like that? So we have border 1, border 2. We have the edge router. Border 1 has 1 session, 1 session. If I would have 2 per each, I would have ECMP on these boxes here. So I get a 192.168.1.0, next hop 10.1.1.1. We have administrative 200. So where is this route here? Where is this coming from? From the leaf here, right? Down here. So we learn this in here. We take it, we advertise it over to the edge router, and the edge router sees that with the respective next hop, which is the 33.5. And when you look at the other routes, which comes here, 192.168.1.0, it has here a 1.1.1. We change, reoriginate to the other side. 10.1.3.3.2 is the local interface, 1 is the neighbor interface, and what do we have here? We have 10.1.3.3.1 in that case. And what else did we do? What else did we change instead of just the next hop? We changed the administrative distance from 200, which is iBGP learned within the fabric, to 20, which is eBGP learned on the outside. Done. Literally done. This is simple and straightforward. And why is it simple and straightforward? I come from BGP and go to BGP. No redistribution needed. No filtering needed between the protocol. Can I still filter? Absolutely. BGP session, route maps, everything you could think of what the BGP protocols delivers you can be used in this case. Politics can be enforced. BGP is a political protocol. It's about I can do everything, even if you allow it, I can still filter it out and in, and etc. Yes, sir?
So if we look at that spine, your assumption there is that, let's assume the left side is like the data center, right?
That's correct.
The rest of the data center edges, leaves are connected to that same spine.
That's correct.
So, but InfoSec would not like that. I mean, they would want like a firewall, just firewall that off between the spine and the other leaves.
Okay, so question is, if I want to have a firewall in this scenario, where would be the firewall at that point? Right, very good question. So you can attach the firewall to the borders. You come in VRF1 to the border, go through the firewall, you go to VRF external or whatever you want to call it, you would go then. So you would go in the overlay tunnel through the firewall out as an example, or you can have it on a service leaf on every other leaf. You go from VRF1 to VRF2 and then VRF2 you go to the external world. So here, we're not looking at where do I put the firewall? Because the firewall has to be somewhere, I guess. It could even be external. We're looking at the connectivity, how to get the connectivity going. But very good question, by the way. Thank you very much. So let me go forward here in scenario 2. And I'll try to be positive, because I know you guys like IGPs. And you probably have a campus network which runs EIGRP, ISIS, or OSPF. But I want to make you aware of a couple of things why I'm not so fond of this scenario. You will see it. So let's start, same scenario. We have again our sub-interfaces. Sorry for the typo, it's the same typo as before. Configuration is fixed. And you see we have here the same IP address shebang as before, with one difference. Now we're putting OSPF on these links. Before we had eBGP, now we have OSPF. Great, configuration is here. OSPF is super easy, right? But you have one problem at that very stage, because if you just configure OSPF and you had EVPN within the fabric, who is taking care that the BGP routes go into OSPF and the OSPF route go into BGP? So how are we going to do this? Redistribution, right? Network statements. Have you guys ever filtered within OSPF 2 routers in the same area? It's a good question for a CCIE exam, right? So it works. And when you look at this, you really can make this work. It is in the steady state, initially say that, by the way, I'm only going over these slides a little bit faster because there is no magic in them. I'll point out the exact magic which comes in when we need to do something, and that is here. We didn't have the necessary routes from OSPF and BGP or BGP and OSPF. So we need to do a redistribution or network statement or something like that. Do you guys like mutual redistribution? Host routes from EVPN to the outside. Remember, one more thing. When we use iBGP within the fabric, these are internal routes, and internal routes don't go automatically in OSPF, so you need at least one route map to make that work. And then you probably need another route map for filtering the stuff inside. So I have that here. You have the configuration snippets, and now suddenly we have the routes, right? Hey, here they are. These routes are great. I have them. LSDB, everything looks good. Does everything really look good? So you remember before, we had 192.168.1.0 or whatever it was coming from the fabric, advertised over B1 to ER1 and B2 to ER1. Same scenario here, right? Routes comes from here, goes to B1, advertised here, B2, advertised here. You guys remember? Yes, everyone remembers? So what do you guys think? What happens now? Why, if I have 2 routes coming from internal to B1 and B2, the same route, by the way, is now suddenly only seen on the edge router once? preferred. Why is it preferred? Yeah, but they both have the routes, right? Both learn them from internal. They see it. So why is one preferring it over the other? Administrative distance, ever heard of? So my 200 route here, I advertise outside, becomes a 110. OSPF is 110. The guy here sent also 200 out here. What will the edge router take? Definitely not the one with 200, right? Why should I? So what we do is, border 1 advertises its fabric internal route because he was the first. Maybe let's say he was the first or the preferred or whatever best path decided. I send it out to the edge router. The edge router says, oh, cool, 2 routes. Let me send it back in. Because that's what OSPF does, it sends it back in. And then back here on B2, what does B2 do? IBGP route, OSPF route, who wins? Oh, that must be an external route. AD is better, I use external. You lost your ECMP. Your convergence will be in the seconds at that point. Just because of this freaking administrative distance. Or mutual redistribution. Or, right? So the problem here is you have a lot of ways to fix this. You can. I have customers changed AD, a customer who did filtering, network statements, summaries, whatever you want. And then sometimes they do an upgrade or call me and say, man, we had an outage last time. I say, well, you can solve that problem very easily. Straightforward, use BGP. Sorry, I'm bad on this one. I'm sorry, very sorry. But why do I want to make my life complicated? I understand. All of you probably have an IGP running in the rest of the network you have. Perfectly fine. But why do you want to tinker at the worst point where you have 2 different worlds coming together, the most complicated piece, because you have VPN to non-VPN, right? Why are you not doing it just at the edge router, where you just need to do a little bit of redistribution, and you probably anyway have to do some additional things. And by the way, on redistribution you can filter. So no need for doing any OSPF filtering of getting the host routes out versus the subnet routes, whatever else. So again, it's an advice, sorry. It's solvable, but it's not simple. It's typical CCIE scenario. For routing switching, you guys were all through that. I leave it to all of you if you want to do that way, it works. I'll give you the smiley on the bottom. Now, third scenario. This is one which comes up a lot when we have discussion, mostly with firewall attachments, gentlemen, to your question from before, but also to the rest of the world communication. I want to use a VPC port channel, layer 2 multi-pathing, for connecting my fabric to the external world, and I want to use the BGP session on SVIs. Who wants this? Are you sure? Are you sure? Not just port channel, a VPC port channel, multi-chassis link aggregation. Who wants it? Really? Are you sure? Okay, I'll guide you through what you have to take care of, because I will do it anyway. So, similar scenario, edge router, borders, but now this is a VPC domain. By the way, when you do this, some things in the fabric change as well. You have now virtual IP address, so you have things like advertise PIP in order to do overlay ECMP, et cetera, et cetera. But the point is, when you use the SVI, you're not using the physical interface. So, physical interface, layer 2. Anyone knows about something fancy called auto state on SVIs? When the last port with a VLAN goes down, the SVI goes down. I have a peer link now. Will the VLAN ever go down? Just think about that, right? So you're waiting basically, to a big extent, on the hello protocols of the routing protocol to decide a down. But that's not the big issue, guys. Let's be honest, this is not the big issue. Here's my SVI, by the way, interface VLAN. Can you see my interface VLAN IP addressing? Does it look strange to you? It's the same IP, 1033.1.1 it should be, .1.1 it should be. It's the same IP on each of them. It's what we call the distributed anycast gateway. That's cool, right? Here we have another SVI, .2. It should be 1.2, same subnet. Man, my fingers are getting stiff. It must be the additional COVID pounds which were coming in. But anyway, you get here the config outputs. I now have to deal with layer 2 first. So I have to make sure all my layer 2 boundaries are correct. Think of BPDUs. They will go between these two nodes. So make sure your other pieces are fine. I'm talking about this link here. Now suddenly this is a layer 2 link. Behind you have an SVI. So you're going through the whole layer 2 pipeline, and then you go to the layer 3 pipeline. Just more things to do. But now, when we go into the BGP routing configuration, the edge router has one neighbor. What's the neighbor's IP address? .1. To who will I create now a session? So let's think of it. He initiates, right? TCP SYN. SYN goes over to the edge router. ACK comes back to the top. Will we ever form a session? No. Right? Will not. Let's come from the other side. Edge router sends a SYN, goes down here over that link. He responds with an ACK. Here we go. We have one BGP session up. Will we ever get the BGP session up here on the top? The answer is no. Why would I want to create a session with 2 times the same IP address? By the way, it's not 2 times the same IP address, it's the same IP address. It's just distributed on 2 systems. So while you will get a session up and running, one session, you will never know to which one. You just don't know. You can go to the borders and say, hey, here it's up, on the other one, or on this one it's up. I have somewhere the show IP BGP summaries are wherever in there anyway. So I will have it up at one point, right? But I don't know where or when or to who. And what happens if the worst link, exactly that link which carries the BGP session at the current time goes down? How long will it take to reestablish the session to the other border? So you have an undeterministic behavior. You might go over the peer link and do the SVI, or you might go straight. You just don't know. So from a troubleshooting perspective, you have more to work, right? You have more moving parts. And the question there is, if you want to do port channel troubleshooting first and then afterwards routing troubleshooting, why you're not just using ECMP on the physical links? Deterministic, link down, protocol down, route lost. Link up, protocol up, route learned. Question over there. That's correct. Okay, so I think the statement is, if I don't use an Anycast gateway but an individual SVI with an individual IP address, can I make it work? Absolutely. Yes, you could. But then, gotcha, that VLAN where you put the SVI with individual IP addresses, you cannot extend with VXLAN. You can only use it as what we call a local SVI. A VLAN with an SVI with an IP must be an Anycast gateway if it is VXLAN extended. If you remove VXLAN extended, it's a local SVI with an individual IP.
That's an external one.
Yes. I don't know if you need to extend it. I don't know. I'm just giving you the rule set, right? And that's the point, right? Again, coming back to this slide here. It works somehow, in some way. We have link redundancy. We don't have really routing redundancy at that point. And the solution to use a problem, to your point, I can use local SVIs, not Anycast gateway. That was one of the proposals. My preference is, if you really want to do a port channel, use loopbacks. Much more deterministic, and BFD works better there if you really want to do that. And then if you can go back, use layer 3 ECMP instead of a port channel. Again, you want to go back to deterministic fabric exit and entrance. And I know you guys have different use cases. I'm just giving you here a little bit of thoughts. When you go in these designs, what do you need to take care of? Sounds simple, but it's not straightforward, right? You have to think differently when you want to do this. And the whole reason of these 3 scenarios is to show you simple if you know what you do, a little bit more to think about. That's all I wanted to give you guys. This is not about you must do 1 and never go 2 and 3, because I proved to you 2 and 3 works. And I proved to you 2 and 3 actually have viable configuration knobs in order to make it work. If you want to do that operationally, I leave that to you. I want to give you the guidance, right? That's my aim to be here. We're good in time, by the way. We should be good in time. We have another thing which we can do. We call them gateway modes. So let's see a little bit differently built fabric. You see my leaves. You see my spines. I think I'm trying to go back up here. You see my leaves here. You see my spine. You see my border gateway. So this is now a special type of an NVE, because this is a type of NVE or VTAP who does stitching of VXLAN tunnels. So we will have VXLAN EVPN here. We will have VXLAN EVPN on the other side. And we do VXLAN EVPN in between. So this is VPN to VPN. It's just a reorigination which we do, or tunnel stitching we do. Here we can do layer 2, we can do layer 3, we can do only layer 3 if you want to use this as a replacement for your L3 VPNs. This is what we call multi-site. Nothing else, tunnel stitching, right? Smart tunnel stitching to get that going. And I want to re-emphasize, it's nothing else than a VXLAN EVPN to VXLAN EVPN gateway. What we looked at so far was VXLAN EVPN to IP Ethernet, right? Inter-AS option A, these SVIs, these port channels to the outside, it was all to IP. Now here's just same NCAP control plane to same NCAP control plane. We can actually do much more than just that, right? We have multiple different modes, and by just doing multi-site between these, here are 2 sites, I just moved it to 3 sites, or N sites, just doing that east-west or here horizontal, vertical kind of interconnection between the 2, I can actually do and take these different VXLAN EVPN fabrics and give them a common exit point where I go either to IP, to MPLS, or whatever else NCAP you have there. So what we call that, it's a shared border. Why shared? It's a shared exit across multiple fabrics. So what we do is, we have VXLAN EVPN in the fabric. By the way, this is just a VTAP, not a border gateway. I want to be very specific. What we do is, we build a little bit of VXLAN EVPN here, so this becomes a gateway, a border in that case. And we do middle orange VXLAN EVPN, red is VXLAN EVPN, VXLAN EVPN to VXLAN EVPN stitching. What the heck? I'm still not in the external world. I'm just in a different NCAP now. Can you give me the exit? And yeah, I can give you the exit further out, right? So you connect to that shared border, your inter-AS option A, your MPLS LDP, MPLS SR, or your SRv6 or whatever you want, because that gateway can do all of it. Do you guys understand what this is going to? Multi-site, anyone looked at it? Understands it? If you guys got it, if not, or if not, both, come see me, I think tomorrow, or I think it's tomorrow, where we talk about multi-site itself. But this is nothing else than an aggregation of multiple individual fabrics, so you don't have to deal with the exit of each and every fabric individually. And it's not really each and every fabric the problem, it's the amount of VRFs you might want to extend from each of these fabrics into that world over here. So you just save a lot of configuration and troubleshooting and do that at one central point. When I say one central point, it doesn't mean like here on the diagram it's one device. I hope that you understand. I just don't show redundancy. I imply redundancy is there. You never want to do just one box. If that one is gone, it's gone, right? So I want to take care on that piece. Then you can also do it differently. Instead of aggregating with multi-site all of these different fabrics and do that shared border exit, you can do an exit right out of the fabric directly. You remember everything to before, we were talking about inter-AS option A. Now we can do here an exit with MPLS LDP. Inter-AS option B, RFC 3107 if you want. We can do that exit here directly from VXLAN EVPN to VPN v4, VPN v6 with the classic MPLS handoff. And we can do it either with LDP or we can do it with option B, 3107. If I don't like MPLS, the old one, the old way, I can do the same with MPLS SR, which is segment routing, the MPLS version of it, and I can do the same. I can do, including the SR part, meaning participation in the IGP in that case from an SR perspective, or I can just do an inter-AS option B, RFC 3107, which is labeled unicast, right? I transport the information in BGP. So I can get an exit here. And you see now the variety you have. It's not needed that you have only one exit. You can do 10 exit. As long as you're clear where you want to go, who you prefer, with what NCAP you want to do. I don't care. This all works, right? And this is all VPN to VPN, so the VRF configuration here on that link is 0. It's here on this gateways when you configure the VRFs, the route import, export. It's here on the MPLS side, on the PEs for that sake. And we can also do that with SRv6. In our case, SRv6 is without USIT, without microSIT, so it's the full expanded SRv6 which we are supporting today. I have a lot of variety, right? Protocols, connection methods. I have NCAP methods. I can shuffle the topologies forth and back, however I like, right? It's all the different versions which we have there. There was a question over there. All this is one tenant? No, doesn't need to be one tenant. So this is multi-VRF. So you can have VRF stretch across the sites. You can have VRF stretch from left to right, wherever you want. And VRF scale is at 2,000. No, I don't have to. No, I don't have to drop that in the global routing table here. Over here, I would do per VRF point-to-point peerings. Here I would use VPN v4, VPN v6, VPN v4, VPN v6, VPN v4, VPN v6. So we keep that all tenant aware or VRF aware. I'm being a little bit not accurate, sorry for that, because a VRF is local on the switch, and as soon as it's between multiple switches, a router becomes a VPN. Apologize if, don't ding me on this in the survey. That was just a little mistake from my side. But now, as we have a couple of minutes left, I want to go through the conclusion we went through all these gateway methods and the external connectivity, etc. So remember, a border is nothing special. It's just a name which I give them. The function is I connect to the outside world. That's what you have to keep in your mind. And the outside world could actually be a VNF, virtual network forwarder, on the inside, right? So when you are a service provider, for example, you have your fabric, and you want to connect a lot of customers, like a B2B service, financials probably as well, a business-to-business service from your leaves, you can do that. And you can aggregate that and punt it out in your network over the borders than on the outside. So border is literally nothing else than a word for something to define the outside to the inside world, if you want so. You saw many methods to attach. Layer 2, Layer 3, point-to-point, sub-interface. Lucas cannot properly write IP addresses and forgets an octet, or he tries to do .1Q NCAP between 2 and 10, which will never work, so apologize for these things. I'll fix them on the slide. And then when we go forward, if you don't want inter-AS option A, if you don't want that, if you want to integrate more, if you say, hey, the outside network is an MPLS network and I want to make it easy, I give you gateways. I give you gateways in multiple ways. VXLAN to VXLAN EVPN stitching, VXLAN to MPLS L3 VPN, VXLAN EVPN to MPLS or L3 VPNs or SRv6. You can choose, right? It's literally just whatever platform you decide to use, which has the capability, you can stitch in between and make the work of assigning point-to-point addresses and configuring point-to-point neighborships by hand easier. Please fill out the survey. Please don't ding me on this couple of typos. I hope you enjoyed it being with me. Give me input if we need to change a couple of things here in that session. It's the first time. If you want to learn more, You can learn, you can train, and you can certify here at Cisco Live. World of Solution, we have a couple of cool things. We launched yesterday something called NXOS Cloud. Maybe you want to go and look into that. It's a cool SaaS platform. And then continue your education with whatever you see here around, get points, and join me for some more session. With this, thanks a lot. See you guys later. Appreciate it.